was a bad day. The internet was in and out. Everyone's wiped out from literacy all morning. Hopefully today will rebound. Get into the weekend. Seems like it's taken forever. Okay, so solve for x. Remember, first thing you do is check and see if it's a right angle triangle. Then you check and see if you have a side angle pair. Okay, I see some people filling in an angle up here. How can they do that? Again?
38, 67.
So they all add up to 180? Everyone remember that from yesterday, which was kind of a haze for some people. 75 degrees is up here then automatically. Okay, so it's not right angle. Then you look for a side angle pair. Because we know all three angles, we do have a side angle pair. Does everyone agree with that? Or sorry, we do have a side angle pair. 67 and 5. Okay, we do have a side angle pair. And then we want to find x, and we do know the angle opposite. So that's set up to use the sine law. Okay, so we want to put what we want to find on top. It's a side. So x over the sine of its opposite angle, according to the sine law, is equal to the side we know over the sine of its opposite angle. So either this way or the 5 over sine 67 equals x over sine 75. How many people have that? Is there equation? Okay, good. Good. All right, so then now how would I solve for x?
You want to bring the sine 75 over.
So multiply both sides by sine 75? Yes, that is exactly what I would do. So that would give me, if you put it in your calculator correctly, .2 centimeters, and it's approximate because we rounded. Okay? Everybody else get that in their calculator, okay? Got to the sine law? Okay, next one. Solve for x. This is 3 centimeters, 48 degrees x, and it's a right angle triangle. Okay. So since it's a right angle triangle, I probably use SOHCAHTOA. I see a couple people use the sine law, and that's fine. You can use the sine law for any triangle, whether it's right angle or not. Okay. But if I'm using SOHCAHTOA, I'm going to label according to the acute angle I'm given, the sides. So this would be my opposite side, hypotenuse, and adjacent. And the side I'm going to cross off because I don't know it, and I'm not asked to find it, is the opposite side. So then out of the three ratios, the one that has adjacent and hypotenuse is cos. So the cos of an angle is its adjacent side divided by its hypotenuse. The cos of 48 degrees is 3 over x. And when x is in the denominator, you have an extra step, and you got to get x up to the numerator by first multiplying both sides by x. And then dividing both sides by cos 48 degrees. So 3 divided by the cosine of 48 degrees is approximately 4.5 centimeters. Okay, did you get that using the sine law one? When you did it using the sine law, did you get the same answer? Okay, so you can use the sine law even if it's right. Okay, next one. Find angle M. So it's a right triangle and you want to find angle M, then you label the sides according to angle M, okay? It's a right triangle and you're trying to find a given angle. You label the sides according to that angle. I didn't work it out, but I'm sure you got it. So according to angle M, this is the opposite side. This is the hypotenuse. And this is the adjacent. When you're finding an angle, it's the side you don't know that you cross off. So which side am I going to cross off here? Opposite. So SOHCAHTOA, which one am I going to use? Cos. So the cos of angle A equals adjacent over hypotenuse. It's not angle A I'm trying to find, it's angle M, so I'm going to change angle to capital M. Adjacent is 21, hypotenuse is 37.4. But now I want angle M, so I have to undo cos. And that is by doing cos inverse. $56 to the nearest degree. Awesome. Okay, so that's using SOHCAHTOA to find an angle. Very good. Next one. Length of side little k. People using cosine law, very exciting. So this is a little k, and that's what we want to find. We don't have a side angle pair, so sine law's out. It's not right angled, so we're in cosine law. So little k squared is going to equal 7 squared plus 8 squared minus 2 times 7 times 8 times the cos of 56. Okay, you could have the 8 and 7 switch. You guys get 50.37039, 50.37039,481. Then we have to square root that. Seven point one centimeters approximately. Okay. Right, I think that might be, no, angle A. Angle A. Two sides of the contained angle. Okay, so I see quite a few people realize that they're forced into finding angle B first. Very good. So it's not right angled as far as we know. We do have a side angle pair right here. We want to be able to do this, but we can't because we don't know the side that's opposite angle A, but we do know the side that's opposite angle B. So we're forced into finding angle B. Once we know two angles, we just subtract from 180 to get the third. Okay? Oops. Approximately 50 degrees for angle B, which means angle A is going to be 180 minus B minus C, which is approximately 67 degrees. Awesome. Good. Any questions about that one? All right, so today we're going to do some word problems that involve, this morning, word problems involving trigonometry. Second lesson is going to be multi-triangle or Okay, so solving problems using trigonometry. So basically, again, we're going to be trying to figure out which formula we will use and then how to set up a problem. Some of them are easier than others. Some of them give diagrams, some of them don't. Okay. Here's our flow chart. First question you ask yourself, is it right angled? If it is, you can use the trig ratio, SOHCAHTOA. If it's not, the next question you see is if you have a side angle pair or a side in its opposite angle. If you do, use a sine law. If you don't, use a cosine law. Okay? So here's our first example. The angle of depression from the top of a 50-meter cliff to a boat is 15 degrees. They give you a diagram, so that's nice. How far is the ship from the base of the cliff? So in my opinion, we're going to have to assume that's 90. Okay? And they want to know this distance. Sorry. Good. 5, I got an add for next week. times. Okay, how does this 15 degrees help us get an angle in this triangle? Jack?
So that line has to equal 90 degrees when it lines up with the cliff.
Awesome.
So we can do 90 minus 15.
Does everyone see that's got to be 90 in there? So if this is 15, then this angle that's in our triangle that we want is going to be 90 minus 15. So that angle there is going to be 90 minus 15, which is 75 degrees. Everybody good there? Yes? Okay.
With that, you can even solve to make sure it's 90 degrees by using the 15 there. It will be the same as the 15 right beside the ship.
Right. You could also have used the Z pattern, like Owen's saying. This is like from grade 9 math, where if these are parallel, then these angles are equal. Okay. Awesome. All right. So 2 ways to take this angle and get an angle that's actually in the triangle we're talking about. Okay. So based off of that and the 50 meters, so if I'm naming it off the 75, my sides, this would be my opposite side that I'm trying to find. Is everybody good? And then across from the right angle is my hypotenuse. And then the cliff is going to end up being my adjacent side. So which side am I going to cross off? Because I'm not asked to find it and I don't know. The hypotenuse, good. So that leaves me with adjacent and hypotenuse, which is which trig formula? So Katoa. SOHCA or TOA? TOA. I have opposite and adjacent, so it's tan. So tan of an angle is equal to the opposite side divided by the adjacent side. So tan of the angle, we know, is 75 degrees, is the opposite side, which we don't know, so I'm going to call that x, over the adjacent side, which is 50. And I want to solve for x, so what am I going to do to both sides? Multiply by 50, yes. So that's going to give me x equal to yep. And then just make sure it doesn't say how to round. Often word problems will say, but this one doesn't, so I just use 1 decimal place then for size. 186.6 meters, and then therefore the ship is 186.6 meters from the base of the cliff. Any questions about that one? Okay, so far so good. All right, how far is Elliot's house, which is here, from the tower, which is here, to the nearest 1/10 of a kilometer? So this is what they want, Elliot's house to the tower, so this is going to be my x. Does that make sense to everybody? And I know 2 angles, which automatically means I know all 3. So the first thing I would do is find that 3rd angle. And I would just do it on my calculator. So I'm going to go 180 minus 65 minus 80 is 35. So this angle down here is 35 degrees. To me, that's given information. If I know 2 angles, I really know all 3, so I actually consider that given. So now I have to decide how I'm going to go about finding x. So is it right angle? No. Is there a side angle pair?
Yeah.
Yes. So I'm going to highlight that, side angle pair. So I know these, and I want to know x. So that's my sine law setup. Okay, with what I want to find on the top. So it's a side. So x over the sine of the angle opposite is equal to sides on top, 2.5, over the sine of 35 degrees. And then to get x by itself, I would multiply both sides by sine of 80. So 2.5 times the sine of 80 divided by the sine of 35 is approximately 4.3. Now, see, it does say nearest tenth of a kilometer, so make sure you do that. 4.3. So therefore, the tower is 4.3 kilometers from Elliot's house. Okay, the next one. How far apart are the ships? How far apart are the ships? Okay, how are you guys knowing to use the cosine law here? There's a couple people that aren't quite sure yet. How are you knowing? Can someone describe what your thinking is and how that you're using the cosine law?
Because you have to find one side length and just two side lengths and
So you see it as a side angle side pattern where you have two sides and the angle between the two sides that you have. Okay. Any other way of thinking about it? Did anyone check for a side angle pair and realize they didn't have one? And then go to the cosine law? Okay, so there's two ways of thinking about it, okay? One of them is like a pattern. If you have two sides and the angle between them, you use the cosine law. Or if you don't have a side angle pair, you use the cosine law. So I'll call this little b. Little b squared is equal to 4.6 squared plus 8 squared minus 2 times 4.6 times 8 times the cos of the angle between them. And that should get you to b squared all in one step. .2 kilometers. Therefore, the ships are 10.2 kilometers apart. Everybody okay with that one? The calculator. Right, the next one. Keisha stands at a point between two trees and measures the angle of inclination to the top of each to be 34 degrees, as she shows in the diagram. One tree is 23.6 meters in height, and the trees are 60 meters apart. Determine the height of the other tree. Anyone have an idea, a strategy that maybe you could use to get to the answer? Doug?
Well, I know that, you know, the two angles are not, you know, fair for the other tree.
Okay, so we know both these trees have a 56-degree angle at the top. Okay. Yep.
And then can't you make a third triangle at the part next to the two?
Like this triangle?
And then you can figure out the angle,
That would be a very hard way to do it, but you could do it that way. Anyone have a different strategy? That might be a little bit easier. You got one?
I named it X, the bottom of the bigger triangle,
Yep.
and then I used that to solve for how long that is and subtracted that value from 60.
To get
Found
this.
that one.
To get this one. Perfect. That's the shorter route. You could do what you would do, but you have to do a lot more calculations to get the answer, but you'd still get the right answer. Okay, so if I'm doing this, so I want to find x first, so I'm going to label my sides according to the acute angle I know, because it's Socotello here, 34 degrees. So I know the 23.6 meters, which was my opposite. I don't know my hypotenuse, and I'm trying to find my adjacent. So which ratio am I going to use?
oh, okay.
Tan, okay? Because I want to find the adjacent and I have the opposite. So I want the one that has opposite and adjacent. So tangent of 34 degrees is equal to the opposite, which is 23.6, over the adjacent, which is x. So what happens when x is in the bottom? Joss. You multiply both sides by x. Perfect. So x tan 34 degrees is equal to 23.6. And now I'm going to divide by the tan of 34 degrees. .6 divided by tan of 34 is, if you round to one decimal place, 35.0, because you get 34.988. Does everyone see that? So approximately 35.0 meters. So that's not what they're asking you to find. They're asking you to find the height of this tree. Okay? But does everyone agree that y, that length y here that I've shown, is going to be 60 minus x? Because the whole distance is 60 and the red part's x. So y is going to be 60 minus x, which means y is approximately, thanks Darius, 25 meters. Okay? So now I can put that in my diagram. This side's 25 meters. And I know this angle, so I can label my sides according to that angle, 34. It's right angled, so this is my opposite side that I'm trying to find. And now I know the adjacent side, and I don't know the hypotenuse, so I'm going to cross that off. And then I need the trig ratio that has opposite and adjacent. Which is tan Tan of an angle is the opposite divided by the adjacent. Tan of 34 degrees is equal to h. I use for height of tree because I've already used x and y over 25. To get h by itself, I would multiply both sides by 25. Times the tangent of 34 degrees is 16.9. Now let's see if it says to determine the height of the tree. It doesn't say to the nearest anything, so I'll keep one decimal place. 16.9. So therefore, the other tree is 16.9 meters tall. Okay, two planes leave an airport at the same time. One plane is flying 575 miles per hour at a bearing of north 23 degrees east, and the other plane is flying at 625 miles per hour at a bearing of north 65 degrees west. How far apart are the planes after flying for 3.5 hours? Okay, so bearing questions. You always start off with a compass. So north, east, south, west. Okay, before we do this question, get your whiteboards out and we're going to go over bearings so that you know the angles aren't going to bother you. Unless you've taken physics or you just had grade 10 math, you're probably not too good with them yet. Okay, so I want us to draw the bearing south 30 degrees west. Okay? Once you catch onto it, it's easy, but you just have to catch onto it first. And I don't want it to be in the middle of a question where we're also doing trigonometry. Just get the angles. Okay? So, when you're given a bearing, you start off in the direction that it says first. So we're starting off totally south, okay? And then we're veering off 30 degrees towards west. Now, who knows what the middle of a quadrant is? How many degrees it is? 45, and how do we know the middle is 45? Because each one of these is 90-degree angle. Do you agree with that? So the middle is 45. So you want to draw it so that it's either past the middle or not past the middle when you draw your angle. You don't have to use a protractor, in other words, but you do want it to either be middle, past the middle, or not, or before the middle. So if I'm just veering off, if I'm going mostly south, or if I'm starting off south, and I veer off 30 degrees towards the west, am I going to be halfway or not halfway? Not halfway. So south 30 degrees west is going to look something like this, where that's 30 degrees. Yes? Okay, so keep the rest of it, but see if you can just erase this one. And now we're going to do north 70 degrees east. North 70 degrees east. Okay, so we start off north. 70 is more than halfway, so we're going to be going more towards the east. So that angle there is going to be 70. Everybody good? If that angle there is 70, by the way, what's this angle in here? 20. Why is it 20? Because it has to add up to 90. Everybody good there? Okay, let's try another one. Okay, let's try west, 40 degrees towards the north. West, 40 degrees towards the north. Awesome. Okay, so I'm seeing tons of pictures that look like this. So it's more towards the west with a 40 degrees in there. So first west and then 40 degrees towards the north. Everyone think they got bearings under control now? Okay, so we'll go back to the question. So two planes leave an airport at the same time. One is flying at 575 miles per hour at a bearing of north 23 degrees east. So draw what you think north 23 degrees east is going to look like. Just draw a line, representative line. We'll adjust their lengths after, so use pencil. But I think it's like this, where that's 23 degrees. So not halfway. And the 23 degrees is between the north and the line I drew. Pretty good there. So that's our 575 mile per hour plane. So now I'm going to draw on our next plane, 625 mile per hour plane, which is at a bearing of north 65 degrees west. What would that look like? North 65 degrees west. So when I draw that line, is it going to be closer to north or closer to west? Closer to west. Okay, so this angle in here is 65 degrees. Okay. All right, now we want to talk about, it's 3.5 hours. So 575 miles per hour means in 1 hour you go 575 miles. So how would you figure out how far you've gone in 3.5 hours? Multiply by 3.5. Good. So 575 times 3.5 is going to give me how far I've gone in 3.5 hours. So I went 2,012.5 miles. Okay. So same thing for the other plane, 625 times 3.5 is 2,187.5 miles. 2,187.5 miles. And then they want me to find how far apart the planes are, which I'll call D, distance. The distance the two planes are apart. So I definitely have two sides. Do I have any angles? Son?
65.23.
Yes, the angle between the two planes would be if I added those angles together. Does everyone see that? They're inside the triangles in this case, so I can just add them. Gives me 88 degrees between the two 65 and 23 is 88. So now, it's not a right angle triangle. Do I have a side angle pair? No, so I have to use the cosine law. So start off with d squared equals Did you guys get 88528033.338?
Alright, 8, 5, 2, 8, 3, 3.
Okay, you got the same as me for d squared, so 8528033.338. The longer the numbers are, the easier it's to type something wrong when you're typing that in. So it's good to double check. So approximately 2,920.3 miles, and let's see if they tell you how to round it. How far apart are the planes? No. So I just rounded to one decimal place then. So therefore the planes are approximately 2,920.3 miles apart. Okay, the next one. How far apart are Stan and Paul? Okay, so lots of people filling in the top angle. That's lovely. So if you know 2, you know all 3. It's 95 degrees up here. It's not a right angle triangle. Do we know a side angle pair? Yes, we know 2 of them, so we can pick whichever one we want. Or I could have picked that one, but the other one I'm going to use is this one because I want to find this side, so I'm going to call this side X. What I'm trying to find. So X over sine 95 equals, for me, I chose the 265.24. It won't matter which pair you choose. And in cases like this, if they round their sides to 2 decimal places, then you just follow what they do and round your sides to 2 decimal places as well. So normally we would just round to 1, but since they won't use 2 in the question, so we will use the answer. 265.24 times 795 divided by the sine of 51. 340.00. Did you get that? Okay. That's nice. 0 meters. So that's Stan and Paul. So that's A. So therefore, Stan and Paul are 340 meters apart. So B is something different. Thank you so much. That's it for today.
Okay. All right.
How high above the ground is the plane? What's that question asking? It's asking for the vertical distance. If you were to make like a right angle triangle, it wants to know the distance from the ground up to the plane, like just straight up. Okay? So if I focus in on this 51-degree right angle triangle, I'm going to outline it in black. Is there enough information in it for me to figure out how high the plane is? I see Jacob nodding. What do I know? I know an angle and a side, and I know it's right angle. So I've got enough. Okay, so according to the 51 degrees, the height that I'm trying to find would be my opposite side. Across from the 90 is my hypotenuse. And this little bit at the bottom here that I don't know is my adjacent. And I'm trying to find the vertical height, and I know the hypotenuse, so I'm going to cross off the adjacent. Which means for B, if I'm using SOHCAHTOA, which ratio am I going to use? Sine, good. So sine of the angle is the opposite divided by the hypotenuse. So the angle is 51 degrees. The opposite's what we're trying to find, the height of the plane. And the hypotenuse is 190.85. So then I would, to get h by itself, multiply both sides by 190.85. And I get h is approximately 148.3. I guess we should keep 2 decimal places, 32. We round to 2 decimal places, 148.32 meters. So therefore, a plane, hopefully it's remote control, is 148 point, well, I guess that's fairly high, 32 meters by. A bridge is being built across a river. A surveyor spots the point where the bridge meets the north bank of the river from a position 90 meters away. He determines that the bridge must be 120 meters long to reach the south bank. The angle of sight at the north bank is 42 degrees. He puts all that into his diagram for you. How far is the surveyor from the south point of how far is the south point on the river bank? So this would be my X then. So analyze and see if you can come up with what formula or which method you would have to use to do it. Is it a right triangle? No. Is there a side angle pair that we know? No. So that leaves us with the cosine law. Okay, good. So we have side, angle, side. We know two sides and the angle between them. So A $80.3 meters. So how far is the surveyor from the south point on the riverbank? Therefore, he is 80 meters away. B, what is the angle between the surveyor's sight lines? Okay, this is a good question to start. So now we know all three sides. Do you guys agree with that? The only angle in a triangle that can be greater than 90 is the angle between the two shortest sides. So what are the two shortest sides? These two. The angle we're trying to find is the only angle that could be greater than 90. Sine law never gives you an angle greater than 90. If you're finding the largest angle in the triangle, you have two options. One is to use the cosine law to find the angle. And the other one is to find the other angle and then subtract from 180. Those are your two options when you're finding the largest angle. So what does our class want to do? Do you want to use the cosine law to find that angle? Because we haven't done one of those yet today. Okay, so we're trying to find this angle. We'll call it angle A. And we'll use the cosine law to find it, which means we start the cosine law out with the side across. So 120 squared equals 80.3 squared plus 90 squared minus 2 times 80.3 times 90 times the cosine of angle A. And then we slowly try to get angle A by itself. So we can subtract 80.3 squared on both sides. And we could subtract 90 squared on both sides. And we get negative 148.09. Is that what you guys got? Yes or no? Yeah? Okay. And then I'm gonna multiply the -2 times 80.3 times 90, which gives me -14,454 times the cosine of angle A. So I multiply the -2, the 80.3, and the 90. Now I divide both sides by the -14,454, which isn't going to give me a nice number. But I do know that two negatives make a positive, so I just leave this calculation for my calculator to do eventually. But I know that if I divide two negatives, I need a positive to get a positive. If you don't know that in your heart, just leave the negatives and type them both in your calculator. And so get the, well, you will get the right answer. Now I've got cos A, but I want angle A, so what do I do to get angle A? Cos inverse. So angle A is the cos inverse of this. Which is oh, it's close, 89.4. So it wasn't greater than 90, but it was close. 89 degrees. So then, can't really fit my therefore statement in very well, but therefore, the angle between the sight lines is 89 degrees.
I got a 90.5.
Did you do both negatives?
Yeah.
You couldn't have done. Because the only way to get over 90 is if you take the cosine of the cos inverse of a negative number. And two negatives make a positive. Got it? Okay, good. The tree is leaning at 10 degrees from the vertical, so this is 10 degrees here. Shafin walks 15 meters from the base of the tree in the direction of the lean and measures the angle of elevation to the top of the tree to be 38.4 degrees. Determine the height of the tree to the nearest tenth of a meter. Ideas. If this little piece in here they're showing you is 10 degrees because of the Z pattern, then what's this angle in here in the triangle? 80? Because that little tiny bit is 10, so the rest of it's 80. So now I know all three angles, if I know two. So 180 minus 80 minus 38.4 gives me 61.6 degrees up here. So it's not a right angle triangle anymore, but I do know all three angles in the side. So do I have a side angle here? I do. I have this side and this angle, and I want to find the height of the tree, so I'm going to use this pair and call the tree X. So the tree's slanted, it's tilted, but we're still finding its height. Okay? So X over the sine of 38.4 degrees is equal to 15, the side we know, over the sine of 61.6 degrees. And then we would multiply both sides by the sine of 38.4 degrees. And we get 10.6. And it wants it to the nearest tenth of a meter. So therefore the tree is 10.6 meters. One to go. A tower is 780 feet tall. Okay. Your friend is between the tower and yourself. The angle of elevation from your position to the top of the tower is 42 degrees. The angle of elevation from your friend's position to the top of the tower is 71 degrees. How far apart are you from your friend? Ideas. Yeah.
How would you subtract 21 to get a smaller
21 and 8, 71, 9, yeah. Okay.
I don't know why.
180 minus 71 minus 90 gives you this little into here. Anything else we know? Yep.
It's minus 1. I'm sorry.
Oh, this rule here?
I don't know what
This rule here means that parts of a straight line add up to 180. Is everyone good there? So 180 minus 71 gives you 109. So this angle here is 109. And if I know these two angles, I know that one up there, right? 180 minus 109 minus 42 is 29. So in this triangle that I'm going to outline in red, I know all the angles but no sides. Everyone agree? And in this triangle I'm going to outline in green, I know all the angles and one side. So how does that help me towards getting eventually this distance here between A and B? Jack?
Well, the green triangles are right angles.
Yep.
And use self-patella to find the angle of the hypotenuse.
Right. The hypotenuse is what we call a common side. I'm going to put it in blue. Does everyone see that? It's in both triangles, the green one and the red one. It's a common or shared side. So if I find this side, I also know a side in this red triangle, which is the side, this triangle that's ultimately going to let me find x out. Okay? And Jack says this one's a right triangle. So according to the 71 degrees, 780 is the opposite. The hypotenuse is what I'm trying to find. So I've already called this x, so I'll call the hypotenuse y. And then the adjacent, I don't know, but that's going to be the one I cross out. Okay, because I'm not trying to find it and I don't know it. So I need the ratio that has opposite and hypotenuse in it. Sine. So sine of 71, or let's write that formula here. Sine of A, my angle, is the opposite side over the hypotenuse. So the sine of 71 degrees is equal to 780, which is my opposite side, over y, which is my hypotenuse. And when y is on the bottom, I have to multiply both sides by y to get it into the top. Then I want to divide both sides by sine of 71. And then I end up with y to be oops. $824.9. 820, so approximately 824.9, and what are we measuring in? Feet. Does it say? Feet. Okay, so that's the common side now that we found. So we now know this side here is 824.9. So when I'm talking about the red triangle, I now have a side angle pair. I know this side and that angle. I want to find x, and I know its opposite angle. So it's set up now for me to use the sine law to find the distance between the people. Okay? So I'm going to put x on the top over the sine of the opposite angle, so sine of 29 degrees equals the side I just found, so 824.9 over the sine of its opposite angle. And then if I multiply both sides by the sine of 29 degrees, I should have my answer about how far apart the two people are standing. $597.7. And then see if it asks us to round to anything. Nope. Feet. So therefore you and your friend are 597.7 feet apart. It's a 5. Great, that was problem solving with Chris. Problem solving with Chris. Hope the recording works.